Hello and good afternoon. This is Barbara Imhof on the microphone, and you are listening to the Space Specials. And in the studio with me is Niamh Shaw,
Hi, Barbara. Always a pleasure. I love our chats.
and we will have a conversation about recent space events. And we will hear a lot about different things. And Niamh has been to Space Week. So, how was that?
It was terrific. So, just so for people know, right across the world, it was Space Week. It wasn't just in Ireland. So, World Space Week is a charity organization run I think practically voluntarily, and it's all about promoting space. And they have a different theme every year. Sometimes it's around sustainability. This year it was about space and entrepreneurship, and it always runs from the 4th to the 10th of October. And it's an opportunity for people in their different countries to highlight space in their country, and to provide content for schools and teachers to talk about space. And this year was no different. I was involved with. I gave different classes this week to schools. I'm working on a teacher's resource combining space to help them teach science and numeracy and literacy and drama all in one chunk because teachers are always short on time. So
That's great.
something I've been working on for a year or so. And I was doing that. But the highlight for me was I got to go to the open day at ESA, which is always run out of ESTEC, which is the European Space Technology and Research Centre. And this year it was all about science fiction. And it was fantastic,
Fantastic.
particularly Star Wars. So Matt Taylor, a scientist, he's amazing, is a mad Star Wars fan, and so he pulled in all his contacts, I think, around Star Wars, and then. Also, then Space Rocks is a kind of a steam based kind of an event that happens regularly in the UK, and they had a special Space Rocks event at ESTEC, which is their research centre in Noordwijk in the Netherlands, and it was brilliant, Barbara. So you have right across the facility, you can visit like the centrifuge, you can visit the soundproof room, you can visit.
So
Um,
cool.
in the canteen. They have all these different stands where you can pick up
Yes.
posters and stuff. But Space Rocks had speakers who were able to give updates on what the different missions are. So Mark McCaughrean, who's kind of a scientific advisor now at ESA, he gave an update on James Webb, and he launched he showed them a picture where they still don't know where half it was, and he invited people to look at it, and if they identify a new star or whatever, that they have that opportunity. We had Olivier Vitas, who is the lead scientist on JUICE, and JUICE is a mission to the moons of Jupiter, which launched in April. And he was talking about that. And we also had Jonathan McFall, who is our latest para astronaut, and so he has the loss of his limb on the lower half on his right leg because they're very interested in the feasibility of people who go to space who may have disabilities, and so he was the first one of it. You met Jonathan? You didn't you say you
Yes,
met Jonathan?
right. Yeah, yeah. There was moon exploration to the moon conference organized by ESA and the Austrian government and space agency, and there he came as a visitor. He's a very nice person, and I think he's so suited for becoming an astronaut. And I just can't believe that he has any problems because he's a Paralympics as well. So
Yeah.
I mean, he's like he probably runs, I mean, like 3 times faster than I do, or
Yeah.
something like that.
Yeah. Well, so he was giving an update. So they started the feasibility study, and he was just giving an update on what's been happening. So he's at the Astronaut Centre in Cologne with the other new recruit of astronauts, of course, who are coming along. And then, lastly, if you are a Star Wars fan, it was amazing because Matt Taylor is also part of the Dutch. What is it called? The Dutch flyers.
André
The Dutch.
Kuipers.
Andre Kuipers was there. He was the Dutch astronaut, but Matt Taylor, being his Star Wars guy, has his own stormtroopers uniform. And he's told me about it in minute detail. Like, it's not a costume. He doesn't call it a costume. He studied it, and he has a replica of a stormtrooper's
Wow.
uniform. But he's part of a battalion of people who are also mad into Star Wars. The Dutch, the 52nd Battalion, and they're all characters from Star Wars. So Darth Vader was
This is
there,
so incredible.
all of Darth
Wow.
Vader's commanders, and in the Hertz room, which is a soundproof testing room in ESA, they had a TIE fighter, which is the ship or not the ship, it's the fighter plane that the dark side have. And they had a tesseract from 2001: Space Odyssey in the squash room, which was lit from behind, and on the soundtrack to 2001: Space Odyssey was played with the one of the James Webb's images on the back wall. It was amazing. It
It
was
sounds
amazing.
like that. I've missed something.
I think everybody should go, and I think if particularly if you're in Austria, it's easy to get across. So that's what happened. And then let's talk about your recent amazing news on October 12th. Of course, your article appeared in Nature magazine.
Yes, so the title of the paper is Laser Melting Manufacturing of Large Elements of Lunar Regolith Simulant for Paving on the Moon. So it seems like a very complex title, but I'll explain it a little bit. And the paper is also can be downloaded for free on the nature.com site. And it is about using a solar ray, or we substituted the solar ray with a laser ray, and sort of concentrating that onto regolith, that is the lunar sand. We used a simulant, so not a real lunar sand, but something which has the same properties. So we used lunar regolith simulant, and we concentrated a laser beam onto this regolith simulant to melt elements that have a sort of
Yeah,
triangular shape and that can be interlocked, so we can use them as sort of more flatter paving elements. And maybe just want to give you a little bit, so why do we need that on the moon? I mean, why do we need something like that? It is because the lunar dust is very abrasive,
yeah,
very fine, magnetic, and it gets into everything. So when you see the Apollo astronauts, when they took off their helmets, all their face, they looked like miners. It was just dark gray because the dust, really, got under, into their suits, into their really tight space
wow,
suits, and and they were covered with dust on their skin, and that is, toxic to humans, but it's also not very good for machinery because it also goes into the electronics, and it also even with the spacesuits, the taking off the gloves or could have been complicated because of the sand in the mechanism. So that's why we want to avoid the dust in the machinery, in the suits, on humans, etc. And to do that, so when we go over the lunar surface, we always immediately create dust, by the movement. And when we have sort of a paved main traverse roads, let's say, then we can sort of mitigate, we can lower the dust um, um, amounts in the machines, and or on people, and this is why this is interesting. And so we try to normally when you start developing technologies, you use a small setup, you use
yeah,
small
yeah.
samples. And so with this particular test, we really made elements in a one-to-one scale, so they were approximately 30 by 30 centimeters or something like that. And it was a large laser beam of around 5 centimeters. And and when you create sort of a beam or go over a sand surface to melt the sand into an element with a rounded beam, then of course you cannot describe perfect angles
Yeah,
or sharp
yeah,
angles, but you get rounded angles. So it has it's a sort of triangular shape, but it's rounded and it
yeah.
has a little bit of an ornamental touch, and you can sort of interlock it
Lock
on
them.
the
Brilliant,
lunar surface.
brilliant.
And
So did you make those bricks? Like we'll call them like triangular bricks. Did you? Wow. So that was your, because there's pictures in the article. Like I've seen the pictures, and I was wondering if they were
so
your
we
from your.
were, as architects, we were responsible for creating the geometries and to sort of alongside work with the engineers and the scientists on developing these geometries so they actually fit the beam. And we also tried different sizes of beams from 10 centimeters, to 5 centimeters in diameter. And of course, we had partners. The lead partner was the Institute for Material Testing in Berlin, together with the Technical University in Clausthal in Germany. Then there was the University of Aalen as another, lead partner, and we were sort of the fourth partner in that team. It was an ESA contracted project, and it was really about advancing the technology and the readiness level of the technology. So we had a sort of a huge setup. We had, the laser beam was sort of via mirrors going onto a surface on the floor, which was, or a box where we had all the sand layers. We also created 3 layers on top of each other, so that was also possible to create thicker elements. And together, with that team, with the scientists who looked at the material itself, with the engineers who also had the setup, and created sort of the programmed the computers for the automated process, and with us being responsible for creating the scenarios. So, what are the applications and the geometries for the sort of paving
Wow.
stones?
Wow.
Together we could manage this, and I think that is
Amazing.
important. It was really sort of a very interdisciplinary teamwork.
And when was that then? How long ago was that work done?
We finished the project last year, 2022, so a year ago, and it ran for 1.5 years.
Yeah.
And so we did a couple of tests. I think we did at least 3 main tests, and then in between there are smaller
Wow.
tests with the setup. It's quite a special setup because it's a very powerful laser beam, and there are not many facilities close by where we could test this. So we were lucky to be part of this project.
And then how did it get into nature? That in itself is an achievement.
Yes. Yeah, that was sort of after, we had some really good results also
Yeah.
from the samples, because we had really these like huge one-to-one samples. We thought, or a couple of people thought, they would want to, try to get a Nature publications, because, always on these projects there are PhD students
Yeah. Yeah.
supporting, and they
Yeah.
are really doing a lot of good
Work.
work, and so they are interested in, publishing in high impact journals. And Nature, is sort of in the
The
top
one.
league of these journals. So they just gave it a try, and we started working on this paper. And it was a longer process because you get feedback, you have to incorporate feedback, and so on. And then they finally it went through. It was accepted, which was already like we were
Amazing.
already very proud. And then the other thing was that Nature then decided. Um, the organizers decided, and the reviewers decided, that this was a very interesting topic, so they wanted to make it a special thing. And what they did was that they created a press release for their accredited selected
Yeah.
audience,
Yeah.
so news agencies, newspapers, etc. And um, and said, okay, you can sort of be the first ones who can sort of
Talk
run,
about it. Yeah.
yes, and talk about the topic and talk about this paper, and everybody is allowed to only, from the 12th of October at 4 p.m. Middle European time to publish it, and and then only afterwards all the other
Yeah.
newspapers and journalists and whoever can take on that topic. And so it was quite interesting to see, because I didn't know this kind of process before. So we had interviews, but nothing was published. We had interviews before the 12th, but
Yeah.
nothing was published before the 12th, 4 p.m. Middle European time. And then suddenly, everything like boom went out, and we were like, being 4 partners, you have quite a
Yeah.
lot of people to interview. So each of the partners gave interviews, and And so on Thursday, 4 p.m., he just, started with the, special people, the news agencies and so on. And then it just went out and flooded sort of the news, until
It's
this
incredible.
weekend.
Incredible. And it is, and it's such a great project because, with this issue with the dust being just so aggressively, gets into everything, roads will be essential. So to do something that fundamental, it's just terrific. So congratulations. I mean, I can imagine that that's going to really help you guys do even more of the kind of work that we have to do in order to, how do we create infrastructure on the surface of the moon and then onwards to Mars. It's terrific, Barbara.
Yes, we already, of course, have some ideas how to continue, and especially the setup is still there. So we hope that we'll, can continue that work a little bit further because, the technology is not there
Amazing.
yet to be, put on the moon. And of course, we believe because it's a technology where you can really only with the sun and the sand,
Yeah.
they're, on the moon in abundance, you can produce valuable building elements. So I think that is sort of very intriguing because it's also a very sustainable way of producing
Yeah.
needed elements.
So that's really interesting. And then I guess what's really interesting is what I've been finding fascinating in the last couple of months was that back in 2020, in the midst of the pandemic in October, um, I was doing I was doing programs for children for our channel, our terrestrial channel, and one of them was this mission at NASA called Osiris Rex, and it was going to an asteroid, and it was going to try and collect a sample on the asteroid Bennu. Now, Japan had already done one for Ryugu. So, and my report starts with, where will you be on September 24th, 2023? And I go on and I explain the whole thing. And suddenly we were coming up to September 24th, 2023, and bang on to the date, the return of this sample that they had taken from the asteroid Bennu was making its way back to Earth, and it was
Incredible.
going to be dropped onto Earth on September 24th, 2023, and they even knew it was in Utah.
It's
And
incredible.
incredible. So this was like a 7 billion uh kilometer mission from start to finish for this, and then the spacecraft deployed, dropped the asteroid dust onto Earth in this capsule, and then went on, and it's gone off to look at another asteroid. And then the other crazy thing was, since October 2020, I've met somebody and I was married. At the time when I made that video for kids, I was on my own and living in Ireland. I hadn't even moved to Strasbourg, and he's from Utah. And a few weeks previously, or a few days previously, his brother died suddenly. So we were actually in Utah on September 24th, 2020, just 100 kilometers or so away from the drop zone of this asteroid dust. So there was so many kind of weird thoughts going on in my head around this. I couldn't believe it. And it was amazing. It really was amazing that
What a story.
like 4 billion year old dust of an asteroid was collected, and the University of Arizona were the lead researchers on it. So they were out there, they collected it, they brought it to a clean room to make sure that it wouldn't that there would be no contamination from anything from Earth, to make sure that this dust was really, really old. And the importance of this mission, so we know already what's on a comet. We know that there's life forming molecules on a comet, but this one was particularly interesting because it was dust that predated the beginning of Earth. And so they felt that if they can prove that there's life forming molecules on asteroid dust, more than likely there's life forming molecules right across the universe. And so on the 11th of October, which was just the day before your big announcement in Nature magazine, they had a press conference. And just from their initial sampling, they have confirmed that they have picked up the presence of carbon and oxygen molecules, or not carbon and water molecules, in this dust. And this is the biggest grab of dust that they've had from an asteroid. So the Japanese mission just had a couple, and they were only hoping to get, I think, 40 grams, which was 60 grams, which was 15 teaspoons. They actually got way more. They got 260 grams. So that's going to be
Wow.
distributed around the world now with different researchers to determine other things.
This
Like,
is amazing.
amazing. So it's like, I feel like it's the first piece of a jigsaw that's going to help us understand more about our place in the universe. Because, when I was growing up, I was told that we were the only system of planets that orbited a star. And now, of course, now we know there are hundreds and billions of exoplanets. And then, we always felt that, well, we're very lucky that we're the only planet out there that has these life forming molecules to promote life: carbon, oxygen, water, and nitrogen. And of course, now we know from a comet that's not true. Now we know from an asteroid that's not true. But now we also know that, something probably kickstarted life on Earth, and the probability that there is another planet out there that has a similar combination, maybe not identical, is probably more than likely. And more than likely there is life. We don't know in what form it takes or whatever. Like, we value intelligence, but that doesn't necessarily mean other life forms have. So it changes the story dramatically that we've been talking about ourselves. So when you think about the early days, when it was heliocentric, when we thought, everything revolved around Earth, that the sun orbited Earth and everything, and in just like 600 or 700 years, how much that story has changed. What do you think about that?
I, I think it's it's incredible. I was just thinking that Galileo Galilei, he sort of started with the heliocentric
Yeah.
worldview, and before, everybody thought, okay, there's the Earth, and even before, the Earth is flat, or all these kinds of things, and now it has sort of taken up speed, because the way we are sort of producing information, and creating knowledge and knowing more about ourselves, about the universe, about sort of where we live, is just as an is it has an amazing pace, which is sometimes really hard to follow and to comprehend, what that actually means. So, I mean, to me, of course, this is fascinating, but it also, maybe creates a little, creates humbleness, because, we're just sort of one little,
Yeah.
part in this like huge, immense cosmos. And yeah, I think that is quite, that it's quite good, sort of to get, or to take that perspective once in a while, to sort of, sit back and just get a slightly different view on the
Yeah,
world.
and I think, it's hard for some people to get their heads around, because I do think just living, you kind of forget that you're on a planet a lot of the time, and you're spinning, and then you're going to go around a sun once a year. But yeah, I agree with you. I think for some people it freaks them out, but I think for me it makes me feel very privileged. And somebody I know says it, Niall Smith, who runs Blackrock Castle Observatory, he said how incredibly lucky we are that our molecules, or even if you go on a subatomic particle, that our quarks and leptons decided to create us. The randomness of it. It is really quite incredible that there is life at all.
Yes.
But I think in the last 2 years, I think that the whole area of space exploration has just been incredible. Like, all these, and I guess it's because these space agencies are now coming into like 50, 60, 70 years old. So the big ideas are now starting to deliver, because they've sent out spacecraft, and it's taken them 10, 20 years to design these spacecraft. And so you have something like James Webb that's giving us back images of our universe, and we're finding stars that are way older than we thought. Um, and, and and at the same time, then we have these missions like, to Saturn, or we've got JUICE now going to Jupiter, but then you also have the Europa Clipper there, and you have all the previous missions, and all these stories are starting to kind of coalesce around the fact, like, there will be life in our universe. in a different form. And I was talking to Elizabeth Tasker. We were talking about World Space Week, and she was involved in an event that I hosted for teachers, just to give teachers to have access to these world renowned explainers and stuff. So Elizabeth Tasker, her area of expertise is exoplanets, and she was saying that the whole thing now about is coming up with that answer about what is it, what does that word mean, life in the universe. And she feels that this is the big science mystery that's going to be solved in the upcoming generation. So people that are in college now, hopefully people that are listening today that are 15, 16 years of age, this is going to be their work. This is going to be the stuff that they're going to be answering on the different science missions, and that's the generation that's going to come up with its answer. And she was kind of getting irritated with the press because they wanted this unequivocal answer, is there life or whatever. And she said you just have to wait, because that's the that's the that's the answer that is for the next generation. It's not for us to do that. You have to give them the time to study that. So I really liked it. And she also talked about our perception of time, and how our perception of time we keep putting our perception on time on the story of the universe, and we have to find our place. And the same way, that they say butterflies only survive a couple of days, or bees, the lifetime of a bee is 3 weeks. And so they probably think of time in terms of like 3 weeks. And so, you can't see the universe through the eyes of a bee, because a bee would miss it. And in the same way, we can't see the life of the universe through our lifetime. And that might seem like really, really long, but it's actually not.
No, it's just less of an eye blink.
I think it's an amazing way to see ourselves. And it's like what you say, I said, it's deeply humbling, and it's necessary. I think it's really necessary for us to start seeing things that way. And then the other thing, then, just related to that, then, it's just there's so much happening. So on the 13th, so the day after your announcement, they had another launch. NASA had another launch called Psyche, and this is another launch to an asteroid, and that will arrive at the asteroid. The asteroid's called Psyche in 2029, and this is a whole other area. And this is sort of being very forward thinking. So they're particularly interested in the asteroid Psyche, and this is an asteroid that orbits between Mars and Jupiter, so it's sort of in the asteroid belt. But this is very heavy, metal rich, a lot of iron on this asteroid, and
Yeah,
uh,
interesting.
they're very interested in this because they want to figure out, for these asteroids that are very heavy, rich in metals, can they be harvested? Can they be mined?
Exactly. Yes.
And that's a
What
whole
kind of
other,
resources do they
yeah,
present? Yes.
because that's a whole other area about like using our universe. And that presents another, a whole other conversation as well, about the whole idea of, should we, I mean, we're parasites already on this planet. Should we be should we be parasitic going forward, about like taking what's on an asteroid, or not. And it presents a whole other moral question. We could go on and on, Barbara. We want forever.
Yes.
There's no end to this.
Yeah, space resources are a big topic. Absolutely. And
Yeah,
I think we have to also, view it from different perspectives again, and also including an ethical perspective on, how we want to do that, and so on.
I think so. I think so. So we're nearly at the end, so I guess we better sign out and do our
Yes, time
farewells.
has flown again. This was an update to recent space events with some, special information topics as well. And yeah, on the other side in the studio was Niamh Shaw,
Always a pleasure.
and I am Barbara Imhof, and we say goodbye until the next episode of the Space Specials.
Thank you.
Bye bye. Thank you.